Hello everyone, this is Dr. Elangovan and I am the professor in the Department of Aerospace Engineering from SNS College of Technology. This video is intended for the open elective students of third year from other branches other than the Aerospace Engineering Department. We were looking at the fundamentals of aircraft and engineering, and in that the final unit on the aircraft instruments is what we are going to look at now. We have something called as equivalent airspeed. The different types of airspeeds are there, and then we have to understand the difference between all the kinds of airspeeds. So this is what will show us. We have something called as an indicated airspeed, the calibrated airspeed, true airspeed, equivalent airspeed, the Mach number, and the ground speed. Now, this is what we have to be clear on the different kinds of the airspeed now. Let's look at this now. How do we understand the airspeed is being measured? In order to measure that, we have something called as a pitot tube, which jets out of the surface of the airplane. To measure the indicated airspeed, aircraft are fitted with a sensor called a pitot tube. The pitot tube is a tube that is exposed to the airflow and can measure the total pressure exerted on the aircraft. Now, the equivalent airspeed is what we are going to also look at now. Equivalent airspeed represents the airspeed at sea level under standard atmospheric conditions that would produce the same dynamic pressure as the actual speed at and altitude of the aircraft. In simpler terms, it is the airspeed a pitot tube with no compressibility errors would display at that altitude. Equivalent airspeed is crucial for determining various aircraft's performance parameters, including control effectiveness, stalling speed, engine performance limitations. The challenge of aircraft compressibility comes up here. As aircraft reaches higher speeds and altitudes, air molecules become compressed due to a phenomenon called compressibility. This compression affects how air interacts with the pitot tube, causing calibrated airspeed or CAS to underestimate the actual dynamic pressure and consequently the TAS. EAS bridges this gap by incorporating a correction for the uh, compressibility, providing a more accurate representation of the airspeed for performance calculation. The calibrated airspeed corrects the instrument position but doesn't account for the air compressibility effects. At high speeds and altitudes, readings become less accurate due to the compressibility. This can lead to an underestimating stall speed and exceeding safe engine limitations based on the calibrated airspeed alone. The equivalent airspeed um, incorporates correction for compressibility, providing a more accurate representation of airspeed for critical performance calculations. So the compressibility correction chart, when applied to the EAS, you get the TAS. Now, importance of EAS for high performance flight: maintaining effective control effectiveness at high speed. And air compressibility can reduce the effectiveness of control surfaces like ailerons and rudders. The CAS readings alone might not be accurate. Left to the reflect this decrease in the control effectiveness. The EAS provides a more accurate representation of how air behaves around the control surface, allowing pilots to adjust their control inputs accordingly. This ensures the aircraft responds as expected and maintains smooth handling of different airspeeds. There is something called a stall speed. Stall speed and EAS. Stalling speed is the minimum airspeed required to maintain enough lift to keep the aircraft airborne. Stalling speed is affected by air density, which changes with altitude. EAS helps determine the and adjusted stalling speed for different flight conditions, preventing stalls. Safe engine operation and EAS. Engine performance limitations and EAS. Modern jet engines have limitations on the maximum power output at different altitudes and speeds. These limitations are often um, based on the equivalent airspeed to account for compressibility effects. Exceeding engine limitations based on CS alone can lead to engine damage. So this far we have talked about the various kinds of airspeed. We have one more video on the airspeed which is coming up in the next video, and till then, we'll